So here's a little exercise in topology. Let's say we have a map. So here's like a collection of regions in the plane, sort of like you'd have countries or states on a map. And let's say we want to color it in like you would color in one of those maps, so that neighboring regions are different colors. The question is, how many colors do you need? Right? So let's say we try it on this one. For example, I might take this first region and color it in red. And then anything that touches that region has to be a different color. So for example, the country that's right next to it here, I could maybe color in blue. And now the country that's underneath them is going to need to be a new color because it touches both red and blue. So let's color it orange. And now I can actually keep going with those three colors for a little while because, for example, I can color in the country that's right below the blue and the orange with red again. And then the country that's next to that, I can use blue. But now I've reached a little bit of an impasse. Because if you see this country right here, it is touching red and orange and blue. So I'm forced to bring in a fourth color. I choose purple, and I'm going to color in this region in purple. And now I'm actually going to be okay with the colors I have. As long as I'm careful, you can make mistakes. So for example, if I grab my orange, if I were to make the mistake of coloring this little region in an orange, I'd actually be in trouble because now the bigger region there would touch red and purple and blue and orange, and I'd need a fifth color. So if I don't want to use more colors than that, I can color the big country in orange, and then the little country that's left, I can use red for. And so I'm able to get this entire map in 4 colors. And it turns out it's a famous result in mathematics called the 4-color theorem that says whenever you have a map like this, you can always color it with at most 4 colors. However, it is really important that this is a map on a piece of paper, so it's a map in a plane. This also works for a map on a globe. And so, for example, these earrings, these are both designs in the plane. They only need 4 colors. And you can tell that they actually need all 4 colors because each of these 4 colors in each earring touches all of the others. But that's as many colors as you can do that with on a plane or on a sphere. If you have a more complicated surface, it turns out you might need a lot more colors. So for example, the pendant here is what mathematicians call a torus, which is just a fancy name for a donut shape. And on this torus, there are 7 different colors, and each touches all of the others. That's impossible on a map that you draw on a usual surface, but you can do it on a torus. So this is a demonstration that to color maps on a torus, you need up to 7 colors. If you add another hole, if you make a double torus, a 2-hole donut, this bracelet is a 2-hole donut, you actually need 8 colors. And indeed here, there are 4 colors in each half, 8 colors total. Each of them touch all the others. And so there are lots of really neat ways that you can demonstrate that. Here's the most recent one that I made. This is a nice little crocheted piece, and it's just 8 pieces of crochet in 8 different colors sewn together. Each one is a heptagon, which is the name for a 7-sided figure, and each of the 7 sides touches a different one of the 7 other colors. So these are granny heptagons, the same way you would have granny squares in a traditional quilt. And so this, which you can see has the 2 holes of the double torus in it, is called Granny's double torus.